Today we're going to complete colligative properties. As we know that we have studied two of them among all four colligative properties, which are lowering vapor pressure, lowering freezing point, boiling point elevation, and osmotic pressure. For today, we will start by boiling point elevation. What is boiling point elevation? Before going through boiling point elevation, I prefer to talk about boiling point firstly. From many years ago, many times we have studied boiling point as some physical properties of liquids, of course, and sometimes for solutions. But in this year, we will study boiling point in different way in terms of colligative properties. Well, boiling point is a temperature when vapor pressure of liquid is equal to vapor pressure of when vapor pressure of liquid is equal to the osmotic pressure, atmospheric pressure. Okay, that means when we heat any liquid, it will start to vaporize. When the vapor pressure is equal to atmospheric pressure, then the liquid starts to boil. It means, surely you know that when we heat any liquid, it won't boil directly. Why? Because it must produce vapor firstly, and then vapor pressure increase until it reach to the atmospheric pressure. When they are equal, immediately the liquid start to boil, bubbling. We will say bubbling. Okay. Boiling point of a liquid is a temperature at which the vapor pressure of liquid is equal to the vapor pressure of osmotic pressure, or is equal to the pressure of its surrounding medium. Well, and now if you note that, I mentioned vapor pressure again. So there's a strong relation between vapor pressure and boiling point. But the relation is direct or indirect, is reverse or directly. Surely it's reverse. It means from now on, any factor that affects the vapor pressure and make it decrease, the boiling point will increase. And any factor that increase vapor pressure, the boiling point will decrease. That means there's a reverse relation between vapor pressure and boiling point. Okay, so look, as I said, when vapor pressure equals to atmospheric pressure, this temperature called boiling point. This point called boiling point. Well, this temperature called boiling temperature. Look, it's very easy. So, suppose that this is atmospheric pressure and the liquid has very low vapor pressure. So it needs more time to reach to the atmospheric pressure. Look, more time. So it needs more energy. That's why when the liquid produces less vapor pressure, okay, it has high boiling point because of it needs more time to be equal to the atmospheric pressure. Okay, this atmospheric pressure is vapor pressure. If vapor pressure is low, so it needs more energy to be equal to the atmospheric pressure. That's why we will say it has high boiling point. But what this atmospheric pressure again? But what if the liquid has high vapor pressure itself? So it needs only a short time, less energy to be equal. That's why there's a few degree of boiling point. It needs a few degree of temperature to reach the boiling point. It's very easy, I think. There's nothing to be confused. So from now on, in anywhere, if you see any question, why boiling point increase, you have to say because the vapor pressure decrease. Why boiling point decrease? Because the vapor pressure increase. That's all about the boiling point. Well, and now let's go through mathematical problems about the boiling point elevation. Same as freezing point, we have some equations to solve any mathematical problems about the boiling point elevation. Well, we have two equations again. We have two equations. Let's see. Look. Okay. We have two equations of a boiling point elevation. Delta TB, did you remember in there we have studied delta TF, but here F change it to B, boiling, equals to KB times molality. What is delta TB? It's boiling point elevation. So what's boiling point elevation? Or increasing in boiling point, or elevation in boiling point, rising boiling point. Well, it's the difference between the boiling point of the pure solvent, okay, and non-electrolyte solution. It means boiling point of pure solvent with boiling point of non-electrolyte solution. It means we have a solution that we dissolve with some non-electrolyte solute, so there will be elevation in boiling point. So this difference between pure solvent and solution called delta TB. KB times molality. KB is molar boiling point constant, same as KF. Did you remember KF? It was equal to negative 1.86 for water. If the solvent is not water, so it must be given by a question. Here, KB for water is 0.51 for water. Okay, if solvent is water, KB is known, which is 0.51. But if solvent is something rather than water, so it must be given by a question. Here, another equation, delta TB equals to this definition, okay? So this definition came from this equation, exactly. Delta TB equals to boiling point of the solution minus boiling point of pure solvent. Did you remember? In there, we have studied delta TF equals to freezing point of solution minus freezing point of pure solvent. And for solvent, if solvent is water, it freezes at 0 Celsius degree. But here, if solvent is water, it boils at 100 Celsius degree. So that's the difference between freezing and boiling. KB for water is 0.51 and boiling point of pure solvent, I mean water, is 100 Celsius degree. Nothing at all, doesn't need to talk about the idea of a question, how to solve any question, because it's very easy. We only need and we have two equations, nothing at all. So for what I need to draw some things? Okay, here I'm going to show you the steps of solving question. No, it doesn't need. We have just two equations. Write both of them in any question and just mark known and given. Everything will be clear. It's very easy. Well, let's solve this one. What is boiling point elevation? Boiling point elevation, it's delta TB, okay, of a solution made from dissolving 20.1 grams of non-electrolyte solute in 400 grams of water. Did you remember? Anytime when you try to solve any mathematical problems about the boiling point and freezing point, firstly you have to identify the solute and solvent. Actually, dear students, it's one of the most important steps, because here can change everything. Non-electrolyte, if I change non-electrolyte to any other solute, everything will be changed. Did you remember? Colligative properties are depend on the number of particles, concentration. So if we dissolve some electrolyte, if we dissolve some electrolyte rather than an electrolyte, everything will change because of electrolytes are behave differ. Okay, are behave more differently than an electrolytes when they enter to the aqueous medium. Well, it's very easy. It's solute, and this one is solvent. Oh, mister, same thing we have here, same thing we have to convert solute into mole and solvent into kilogram. Yeah, same process, same steps, everything for me is repeated here. Okay, it's just a quick revision of freezing point. Well, so now we have to turn this gram using molar mass into number of mole. Firstly, before finishing to read the question, immediately convert gram of solute using molar mass into number of mole. Mole, look, mole equal to mass over molar mass. Easy. Mass is 20.1 divided by 62. Okay, because I'm bad at accounting, that's why I just wrote some results in my paper, so please don't mention this. Mole is equal to 0.324, equals to 0.324 mole. Okay, it's number of mole. And what about these grams? These grams, which is 400, is related to a solvent. That's why we have to turn it into kilogram. Kilogram equals to gram, which is 400, divided by 1,000 equals to 0.4 kilogram. Look. Now we just achieved number of mole and kilogram, which are useful to get the value of molality. It's very easy. So now we can take out molality. Molality equals to mole per kilogram. We have mole, which is 0.324 divided by kilogram, 0.4. It's very easy. So molality equals to 0.81 mole per kilogram. Okay, mister. So I did that before finishing and explaining the things that required by this question. Well, and now we have prepared molality, which is 0.81. Okay. What is boiling point elevation? So we can take out value of delta TB very easily. Delta TB equals to KB times molality. Look, we are looking to get the value of delta TB. KB is 0.51 times molality is 0.81. Look, I just run the equation of delta TB and everything is very clear. So delta TB equals to 0.41 Celsius degree. Okay. And now we have the value of, we are calculated delta TB value. So it's very easy. I can add another thing to calculate. Well, what is boiling point of a solution? Let's see. Because we have solvent, water, which boils at 100 Celsius degree. And now after dissolving 20.1 grams of non-electrolyte solute, let's see at what temperature water boils. I mean the solution. Its solution boils. Okay. So delta TB equals to boiling point of solution minus boiling point of pure solvent. Delta TB is 0.41 equals to, we are looking for boiling point of solution minus 100. So x, which is boiling point of solution, equals to 100 plus 0.41 equals to 100.41 Celsius degree. Water, which previously boils at 100 Celsius degree, but now boils at 100.41 Celsius degree, due to dissolving 20.1 grams of non-electrolyte solute. Why boiling point elevated from 100.41 from 100 to 100.41? Because vapor pressure decreases. That's why it needs more energy by 0.41 Celsius degree to get the atmospheric pressure level. Another one. Okay. Yep. If the boiling point elevation of an aqueous solution containing non-electrolyte solute, again, the solute is non-electrolyte, is 1.02 Celsius degree. What's the molality or molar concentration? Molar concentration. What is molar concentration of this solution? Look, if boiling point elevation of aqueous solution is 1.02 Celsius degree, look, what is this number? You may confuse between boiling point of solution and boiling point elevation. Mister, how I can be sure that this number is delta TB or boiling point of solution? Okay, it stands for which one? This one or this one? Well, we knew that previously because we are using water. Water boils at 100. So its solution is supposed to boil above the 100 Celsius degree. Right? So that means boiling point of solution is a large number. It's a big number, around 100. Okay? Especially if we use water as a solvent. So it's supposed to have boiling point of a solution above 100. But now we have only 1.2. So that means it's elevation. It's delta TB. So if the number is small, it's delta TB. If the number is bigger than 100, it means it's boiling point of solution. That's why surely, without any doubt, I can say it's delta TB. So if we have delta TB by 1.02, what's the molar concentration? Surely it's very easy. Delta TB equals to Kb times molality. We have delta TB by 1.02 equals to Kb 0.51 times molality. So molality equals to 1.02 times 0.51 is equal to, I think this time, I do not use any calculator because of it's super easy. 2 molar. Hopefully it's a correct answer. So the molar concentration must be 2 molar. Right? Look how it's easy. Nothing at all. Another one. Okay. Dear students, it's a very different universe. It's a very different question from the other questions. Just by reading the phrases, the words, you can understand that there is mixing between boiling and freezing point. It is super different question. Let's see how and why. An aqueous solution of glucose. It means we have water, we just dissolve with glucose, and it boils at 102 degrees Celsius. Did you remember? This number is small or above 100. Above 100, mister. So, remember. That means it is boiling point of solution. But if it's small number around 1, 2, 3 or point numbers, so it will be delta TB. So it's boiling point of solution. Okay. Calculate freezing point of this solution. What? We have boiling point and now we are looking for freezing point? How is possible? Freezing point of same solution. So how we can travel from boiling point into freezing point? How we can jump from boiling point to freezing point? We have to look for something in common between them. Which factor, which member of their equations are common between them? Molality. So, any question that contains both colligative properties, I mean, any question that contains boiling point and freezing point, there will be two steps for solving that kind of questions. What are the steps? First of all, you have to convert the known into molality, then convert molality into unknown. So, look, let me explain. To calculate freezing point of solution, if I give you two options, okay, I'll ask you, please, my student, calculate freezing point of this solution. But you have two options, okay? The first one is boiling point of this solution. The second one is molality. Which one will be your selection? Okay, mister, to get freezing point of solution, boiling point is useless, but molality is useful. So, but what? Immediately you will select molality to get the freezing point of a solution. But what if you have only one option, which is boiling point of solution? Okay, mister, it's again useless. So I have to change this one into molality, then I can use molality into freezing point. Because of there's no relation between boiling point and freezing point, but there's a relation between molality and freezing point. So for what I have to use boiling point to get freezing point? No. So I will change this gift into other gift which is useful for me. Okay, I like molality, that's why I have to turn known into molality, then molality into unknown. So you have to use all four equations, two of boiling point, two of freezing points, in that kind of questions. But we will start by known. Okay, so we have to start by boiling point firstly. So we have two equations of boiling point. We are looking to get the value of molality. So delta TB equals to KB times molality. We are looking for molality and we have KB, which is 0.51, but we don't have delta TB. So we have to calculate delta TB firstly. Delta TB equals to boiling point of solution minus boiling point of solvent. Solvent, it's water, it has 100 Celsius degree, so delta TB equals to boiling point of solution is 100.102 Celsius minus 100, which is water. Okay, pure water boils at 100 Celsius degree. So delta TB equals to 0.102 Celsius degree. And now by substituting delta TB into here, we can get the value of molality. So molality equals to delta TB over KB. Delta TB is 0.102 divided by KB, which is 0.51, equals to. So molality equals to 0.2 mole per kilogram. Okay? Now, I just converted boiling point into molality. Well, what if we have molality at the first time, so it doesn't need those steps? But now, because of boiling point is useless for freezing point, that's why I changed boiling point into molality. Then we can use molality to get the value of freezing point of a solution. So, delta TF equals to freezing point of solution minus freezing point of solvent. Look, I'm looking for freezing point of solution. So freezing point of solvent, it's 0 Celsius degree because of its water. Delta TF, we don't have delta TF. So I have to get the value of delta TF. Delta TF is equal to Kf times molality. Delta TF equals to Kf is negative 1.86 times molality is 0.2. So delta TF equals to, okay? Delta TF equals to 0.372 Celsius degree, negative 0.372 Celsius degree. And now by substituting delta TF to here, we can get the value of freezing point easily. So because of solvent is water, freezes at 0, so delta TF equals to freezing point of solution minus 0. So freezing point of solution equals to freezing point of solution. Sorry for my handwritings, please. Equals to negative 0.372 Celsius degree. By this way, we can solve any question that contains both colligative properties, which are boiling point and freezing point. One of them elevation, one of them depression, like this. Okay? So, I think doesn't need to solve any more questions, and now we are going to study something different, which is called electrolytes and colligative properties. What are the electrolytes and colligative properties? Well, hopefully you note that from all the previous questions, when we read the phrases, the sentence of any equations, you have seen that the solute is then electrolyte. But what if we dissolve electrolytes? What will happen? That's why we will study electrolytes. Okay, we will study, look, electrolytes and colligative properties. What is electrolytes and colligative properties? Look, well, what will happen if I put sugar, C6, H12O6, okay, into water? So it's S. So there will be only dissolution, aqueous. Nothing will be changed because of the strong attraction force between the sugar atoms, which are carbon, hydrogen, and oxygen. Water cannot overcome this attraction force, so they stay as a molecule together. That's why they just dissolve. So dissolving 1 mole results 1 mole. But what if we dissolve NaCl? Mister, I remember it dissociates. It will produce Na plus and Cl negative, which are aqueous. It's S. So dissolving an electrolyte at least results 2 moles of ion or 2 mole of ions, dissolving 1 mole of electrolyte results 2 moles of of ions. So surely we have to care. We have to deal with this difference, okay? We have to deal. That's why we will study electrolytes and colligative properties. What will change? Okay. As a quick review, let's take a look at some dissociation reactions. We know that NaCl is a strong electrolyte, is a salt, it's ionic compound. When we dissolve NaCl in water, it results 2 mole of ions produced, or 2 mole of ions produced, okay? So what will happen if we compare NaCl by sugar? NaCl results 2 mole of ions, but sugar results 1 mole of a compound. So what's the difference? That means there will be 2 particles, there will be 1 particle. Remember, colligative properties are dependent on the number of particles. So if we dissolve NaCl, compare it to sugar, sugar will be 1 particle, but NaCl will be 2 particles. So the effect of NaCl is double by comparing to sugar. Okay? So it affects boiling point, freezing point, osmotic pressure, vapor pressure by double. Okay? At double time, it has more effect than sugar by double. Okay? Look, sugar is not an electrolyte. Each sucrose molecule dissolves to produce only 1 particle in a solution. So 1 mole of sucrose dissolves to produce only 1 mole of particles in a solution. So now what will happen if we compare NaCl by sugar? Here we have 1 mole of particles, here we have 2 moles of particles, here we have 1 mole of particles. So of course the effect here will be 2 times greater than this by comparing to here. Why? I'll show you. About CaCl2, it results 3 mole of ions. So that means CaCl2 comparing to sugar affects 3 times greater than sugar. 3 times greater than sugar. And now we can see 0.1 molar solution of sodium chloride NaCl lowers freezing point of solvent nearly twice as much as 0.1 molar solution of sucrose. It means if we have 0.1 molar solution of sucrose compared to 0.1 molar solution of sodium chloride, it lowers freezing point and vapor pressure nearly twice greater than this one. However, they have same concentration. What's the reason behind of this? Because NaCl will produce 2 particles, but sucrose produce only 1 particle. That's the difference. Okay. What for BaNO3? Well, BaNO3 solution raises boiling point 3 times. Look, let's see. BaNO3 solution raises boiling point 3 times as much as sucrose solution of the same molality. Why? And please explain and show the reason. Well, let's see. BaNO3 is an ionic compound. When it dissolves in water, it dissociates to release its particles, its constituents, its ions. So it will release 3 moles of ion or 3 mole of ions. That's why we will get 1 barium cation and 2 nitrate anions. So there will be 3 mole of ions produced. But about sugar, it will produce only 1 particles as a in a dissolved form. So now, if we compare the value of delta Tb that comes from dissolving BaNO3 to the value of delta Tb that comes from dissolving of sugar, surely it's greater than this one by 3 times. Why? Because of here we have 3 moles, but here we have 1 mole. Of course, surely it affects the mathematical problems about them because we have to count number of mole of ions, and we must introduce number of mole into their equations. Let's see. That's why all 4 previous equations must be rewrite again like this. Look, delta Tb equals to Kb times molality times mole of ions. Okay, you have to write this blue part when solute is electrolyte. And for delta TF is the same. So the change will be here only. Every single step is just same, stay the same. The only difference between here and previous equations is this part, the blue part. And when we have to count this blue part, when solute is electrolyte. And let's see the effect by solving only one question, because of all the others will have the same idea. Well, let's read. What is the expected freezing point depression? Freezing point depression, it's delta TF. What's the expected freezing point depression for a solution that contains 2 moles of magnesium sulfate? Magnesium sulfate, MgSO4. This is solute. So just focus at this part. Look, in all the other questions, we have seen non-electrolyte solute. But here it's magnesium sulfate, it's salt. It is electrolyte. So before doing anything, take out your salt, take out your solute, which is electrolyte, MgSO4, and write the dissociation reaction plus SO4 negative 2. Now we will get 2 moles of ions. 2 moles of ions. Okay. If we dissolve 2 moles of magnesium sulfate in 1 kilogram of water, what is delta TF? We know that. It's very easy. Delta TF equals to Kf times molality times blue part, don't forget, mole of ion. So delta TF equals to Kf for water, we knew that, it's negative 1.86 times molality. What is molality? So let's turn those informations into molality. So molality equals to mole per kilogram, mole of solute per kilogram of solvent, equals to 2 divided by 1. Surely it's equal to 2 molar. So just we have to multiply 1.86 by 2 times mole of iron. Mole of iron is 2. So it will be negative 7.44, negative 7.44 Celsius degree as a value of delta TF. Look, dear students, you know it's not mandatory to have molality and mole of iron equal in anywhere, okay? This is in here we get 2 mole of ions with value of molality 2 molar, but maybe it's differ. It's okay to have different value for each of them. So please don't say that they must be equal always. It's possible to have one of them greater than the others. Well, my point is that, again, please, when we write the equations of freezing point and boiling point, you have to focus on solute that is electrolyte or non-electrolyte. Well, inshallah, in next lesson, I will explain and I will solve some multiple choices and I'll show you many different ideas, and we will finish the last one, which is osmotic pressure. تاوانێدا تو بەخواتان دەست پێرم هەر شاد و سەرفراز بن.